Alright, so today we're going to start Chapter 3, which is dealing with accelerated motion. And so for the first section, we're just going to introduce acceleration and talk a little bit about how to calculate it. So there can be two signs for acceleration, positive and negative. And so acceleration we usually refer to as the positive acceleration, and then deceleration we usually refer to as the negative one. So if acceleration is in the same direction as velocity, remember we can use a positive or a negative sign to indicate direction on velocity. So basically this would be a case where the signs are the same. So that means that they could both be positive, which is the common example, or they could both be negative. So it's really looking at, are they in the same direction or not? If that's the case, then the object speed will increase. Okay, and if acceleration is in the opposite direction as velocity, so either velocity being positive, acceleration negative, or velocity negative, acceleration positive, then that means that the object speed is decreasing or it's slowing down. And so it doesn't just, slowing down doesn't just mean when something is negative. Okay, it's having to do with the signs between velocity and acceleration together. So that's really important to remember. Alright, let's look at an example. And so this is figure 3-8 in your book. So you may want to pause the video for a second and go ahead and sketch that diagram. You may want to look in your book. My drawings are not always the best. And so maybe take a second to figure out what you would say about the velocity and acceleration of each object. And then we're going to go through it together. So if you want to pause it here, that's fine. Otherwise, we're going to keep going. Okay, so for letter A, if you remember from the drawing, letter A was up here. So if this is a graph of velocity versus time, we would say that the slope is equal to 0. Well, on a velocity time graph, the slope is equal to acceleration, and so this would also mean that the acceleration is equal to 0. Just like on a position time graph where the slope was velocity, here the slope is acceleration. We could also say that it has a constant velocity, since whatever this value is, the line is constant or the slope is constant. And if we say that this is the positive velocity, and then anything below the x-axis is negative velocity, usually we say positive velocity is in the easterly direction, and so we would say that this is constant to the east. Okay, so now let's look at B. Okay, so B looked like this. So it's starting from 0, because here's our velocity, here's our time. It has a positive velocity because it's all in the positive y, so velocity is y, but you can see here that it does have a slope, so it does have an acceleration, and if we look at the slope, it's positive, and so we would say that the acceleration is positive and constant because the slope is constant. Well, here we have a positive for velocity, a positive for acceleration. We would say that the object is speeding up since the signs are the same. Okay, so now let's go on to letter C. C looked like this. So here's our velocity and our time. So again, we're still a positive velocity, but as you can see, the slope is negative, which means our acceleration is negative. So this is a opposite in sign, positive velocity, negative acceleration, so negative slope. This would mean that the object is slowing down, and then eventually it's going to meet this point right here, which gives us a velocity of 0. So it's going to start at some velocity, slow down until it gets to 0. Okay, letter D was similar to B, except it's starting at a negative velocity and going to a positive velocity. And we also have the whole time a positive slope. So let's focus on this part first. We have a negative velocity, but a positive slope, so this would indicate that the object is slowing down. Then it's going to hit where v equals 0. And so I would say it's slowing down, it stops, and now it's going to speed up because now we've got a positive velocity and a positive acceleration, so both the signs are positive, meaning the object is speeding up. So it starts out traveling west. If we say our negative velocity indicates west and our positive velocity indicates east, because remember, signs on velocity just indicate direction. It's got a constant acceleration the whole time. Like we said, it slows down to a 0 velocity. Then it increases in speed as it now changes direction and heads east. Okay, and the last one that we want to look at is letter E, and E is down here. So this is in our negative velocity, or traveling west, And you can also see that it has a constant slope, which means no acceleration. It's just traveling west at a constant speed. Okay, so now that we've kind of looked at how to interpret acceleration from a velocity time graph, let's talk about how to calculate acceleration. Well, like we talked about, acceleration is the slope on a velocity time graph, which means since slope is rise over run, or change in y over change in x, since our y is velocity and our x is time, it's change in velocity over change in time, and we can break that down because we know any change is equal to final minus initial. So this would be a good equation to put on your note card. So since acceleration is a change in velocity, we know that we can break velocity down into two parts. It has speed, and it's also in a particular direction. So if we change either of these things, that's a change in velocity, which is acceleration. So acceleration could be a change in either speed or direction or both. Usually it's just a change in speed, but it could be constant speed changing direction, which might be kind of hard to do. Okay, so acceleration and velocity are different, but they're also related. They're both a rate of change. Anything that's a rate of change is always divided by time. Acceleration is a rate of change of velocity because it's the change in velocity over the change in time. And velocity is a rate in change of position because it's change in distance over a change in time. Both can have average and instantaneous forms, and in the last chapter we talked about average and instantaneous velocity, and now we're going to talk about average and instantaneous acceleration. And then we will discuss homework and work on it in class. Whoops. Okay, so here are your checks for understanding for section 1 about acceleration. So number 1, what is true about speed when the signs for velocity and acceleration are the same? And what if the signs of velocity and acceleration are different? What's true about the speed of the object? Number 2, what is true about velocity and acceleration if the slope is a horizontal line on a velocity time graph? Number 3, what is the equation for acceleration? And number 4, if you do donuts in the parking lot at 10 miles per hour, are you accelerating? And explain. So give these a try, and we'll go over them in class when we check your notes. Have a good day.